Welcome back. Moving forward, another important concept within the networking area is the OSI model. Before I talk about the OSI model, it's important to understand and know each layer within this model, starting from the physical layer, which is the bottommost, and the topmost being the application layer. And we'll talk about what these layers are, what happens when an information is passed from one computer to the other. So for instance, if you were to send an email, which may look like an easy task, but behind the scenes is in fact the OSI model in action. So in this lesson, I'm going to detail out what the OSI model is all about. So once again, it contains 7 layers, starting from the bottom, which is the physical layer, the data link layer, the network layer, transport, session, presentation, and application. So when a computer sends some data to another computer, obviously the medium of transmission is the cable or the wireless. So the data travels directly from the computer and passes through each of these layers. So this is just the macro level at this point. I'm going to get into the details of each layers, but just visualize data being sent from one computer to the other or to the cable, right? So the data goes from each of these layers before it in fact hits the actual medium, which is the transmission cable or your network cable or the wireless media, whichever you were using. So when the data passes through each of these layers, each layer has a certain function. It does something to that particular data or the bits. So the top 3 layers, for instance, the application layer, presentation, and session, nothing happens at this point. But when it goes through the transport layer, segments are made. In the network layer, packets are made. The IP header, TCP header, and the data remains. And then of course the data link layer also divides the actual data into a frame which contains the MAC address, IP address, TCP header, data, and FCS. So think of this as just simply sorting out the mail, right? So if you were to physically send a letter to a post office, the post office is processing your mail, is checking to see which state it needs to go to, which house address, which subdivision, what to do, what's the name, and so on. So here I'm going to talk about what the OSI stands for. It's Open Systems Interconnection Model. The OSI is a conceptual model that simply characterizes and standardizes the communication functions of a telecommunication or computing system without regard to the underlying internal structure and technology. So whether you're using a star network, bus network, any topology, for instance, any type of transmission media, it doesn't matter. This is a fundamental conceptual model that tells the data to pass through each of these layers, and each of these layers perform a certain function on that data. The model is a product of the Open Systems Interconnection Project at the International Organization for Standardization, which is known as the ISO, maintained by the identification, and you can always look this up. So just know that OSI is a conceptual model. In other words, it's a standard, right? How computers communicate, what happens to the data from one computer to the other. Let's get into the layers of the OSI model. So the physical layer, which is the bottommost next to the network medium or the transmission cable, also known as the lowest layer of the OSI model. So remember, the lowest layer is the physical layer. It's simply concerned with the transmission and reception of the unstructured raw bit stream over a physical medium, which is your network cable. So this layer is the first layer, in fact, to receive piece of information or data bits. It describes the electrical, optical, mechanical, and functional interfaces to the physical medium and carries the signals for all the higher layers. A couple of other functions of the physical layer is data encoding. So it modifies the simple digital pattern which is ones and zeros within the bits, used by the computer to better accommodate the characteristics of the physical medium and to aid in bit and frame synchronization, right? So its function is to just take a look at the piece of information that it receives and then it encodes it, makes sure that all the bits are there. It also determines what signal state represents a binary 1 and how the receiving station knows when a bit starts and where it stops, right? And how it delimits the frame itself. So that's the main function of the physical layer. Next is the data link. So now your data is moving up, right? It hasn't received the user yet. You cannot see it on the screen yet, right? So after it passes through the physical layer, it goes to the data link. The data link provides error-free transfer of data frames. So this particular layer checks to see for any errors within the data or the bits being received from the physical layer, allowing layers above it to assume a virtually error-free transmission over the link. So this is your sort of like, think of this as your guard at your office, right? So it's just checking to see who goes in, whether you're authorized to enter or not. The link establishment and termination, that's one of the functions also, establishes and terminates the logical link between the two nodes. The frame traffic control tells the transmitting node to simply stop or back off when no frame buffers are available. It also performs the frame delimiting and creates and recognizes frame boundaries and error checking as well. So in a nutshell, the data link layer provides error-free transfer of data upwards to the application layer. So once the data is now past the physical layer, the data link layer, the next is the network layer, which controls the operation of the subnet, deciding which physical path the data should take based on network conditions, priority of service, and other factors. It provides routing, for example, subnet control, frame fragmentation, logical physical address mapping. So it takes a look at and sees, all right, which department should I send this data to? Whether it belongs to the sales department, the purchase department, operations, marketing, and so on. So it takes a look at the subnet, the actual IP header, and the address where it needs to go. The subnet usage, for example, accounting has accounting functions to keep track of frames forwarded by subnet intermediate systems to produce the billing information. Moving upwards towards the user, next layer is the transport layer. It simply provides message segmentation, accepts a message from the session layer above it, splits the message into smaller units, and passes the units down to the network layer. The transport layer at the destination station reassembles the message. So the message acknowledgement, for example, provides reliable end-to-end message delivery, and that's important. So keep this in mind whenever you hear transport layer. It's end-to-end message delivery in a reliable manner. The message traffic control is one of the other functions. It tells the transmission station to back off or stop when no message buffers are available. So that's what the transport layer does. Next layer is the session layer. Simply allows establishment between processes running on different stations. So it provides session establishment, maintenance, and termination, allowing two application processes on different computers to establish, use, and terminate a connection, hence called a session. So this is the logical session between one computer to the other computer. It also performs the functions that allows the processes to communicate over the network, performing security, name recognition, logging, and so on. Next is the presentation layer, which provides character code translation, data conversion, data compression, and encryption. So this is where all of these functions happen, which is the presentation layers. So for instance, the data conversion is the bit order, the integer floating point, and so on. The compression includes reducing the number of bits that needs to be transmitted on the network. And of course, the encryption data for security purposes, such as password encryption. So you enter a password, username and password on the internet, and you hit submit. What actually happens is the data goes from your computer to another computer and passes through this conceptual standardized OSI model. And finally, we have the application layer, which serves as the window for users and application processes to access network services. This layer contains a variety of commonly needed functions, and all those functions include resource sharing, device redirection, remote file access, printer access, IPC, known as the inter-process communication, network management, directory services, email, and virtual terminals, and so on. So the application layer simply serves as the window for users and applications. So this is where now the message is right displayed on your screen. Here's a quick summary of what we just talked about. Conceptual model, very important. You need to understand what each of these layers do and mean. For example, layer 7 is application, then presentation, all the way down to the lowest layer, which is the physical layer. The easiest way to remember the layers is just memorize this statement: all people seem to need data processing. Of course, you can make your own as well. But if you remember this sentence, all people seem to need data processing, the first letter of each of these words represent each of these layers. So the letter A in all represents the application layer, letter P in people, the presentation layer, and so forth. So I hope this helps. Take a look at this concept again, understand the functions of each of these layers, and with this, let's move to the next lesson.